Hi guys, Mrs. Grabner here. We are going to be starting off in Unit 9 today, and we are going to be talking a little bit about naming different three-dimensional solids. So I'm going to start off with the webcam here, and I'm hoping that it's big enough for you to actually be able to see. It doesn't let me get it any larger. So we're going to actually be looking at a couple of these different solids and talking about how we name them before we kind of jump into our notes packet. So what I'm going to do is I'm going to move my camera down so that you can take a look at these different solids that are here. And when we first start off with this lesson in class time, what I will typically do is I'll have the students take a look at these different solids and try to see if they can actually sort them into three different piles. So I start off with just sorting, and then we start talking about sorting with three different piles. And through that, what we end up doing is actually coming up with some of the characteristics that the different types of solids actually have. So if you notice, for example, this solid right here, we actually have two triangles on either side, and then those triangles get all connected with rectangles here, which is kind of interesting because this is similar in the fact that it has two polygons on the ends. These actually happen to be hexagons, and attaching those hexagons together are all rectangles. So what I would have hoped that you would do is that if you saw this one, you would actually take a look at it and group it with this one, because they both are two similar to exactly the same shapes on the ends, connected all by rectangles. The rectangular prism, which is right here, is actually the same situation too. You have two matching rectangles on the ends, connected by all rectangles around the sides. We would group those guys together. This right here is another rectangular prism. It is actually similar. It's just a different size than this one that we had over here. So I'm going to group it together over here as well. This one is actually a cube, and the cube is kind of an oddball. The cube really matches with these, is knowing that a square is a rectangle. We see two squares on the ends connected by squares. So technically speaking, this one is actually going to go in with this group of our 3D solids over on this side. However, we're going to actually talk about it as potentially going into another group as well. This one is actually a cylinder. You might have seen something like this before. It's a little bit different. We are going to kind of put this one into our prism category here in just a second. We do have two circles on the ends. It's not necessarily connected by rectangles, but it's connected by one kind of sheet that wraps all the way exactly around. We can kind of put this one off to the side as sort of an other category for right now. These two right here are cones, which is interesting. They come to a point at the top, and they have a circular base on the bottom that you can see right here. The cone only has one base and has this point. So I'm going to actually put this into the other category with that cylinder up front here. Then we have this one, which looks like a pyramid to us. And interesting, there's a square on the bottom, comes to a point up at the top. This one is kind of similar to the cones. There's some similarities between them, a couple of differences that we do have between them as well. But we're going to put this into a group by itself. Here's the cylinder, which would match up here. We have another triangular prism. And then we have this one, which is actually called a sphere. And our sphere has none of the commonalities between these prisms that we had over here, or even these cones that we had over here in cylinders, but it also doesn't match this pyramid. So this is kind of going to go into what I call an other category, and that's going to actually go over here with these guys. We do have, for example, here's one more for you. We have another pyramid here. It has a triangle for the base, which is a little different, but this would go in with our with our pyramid over here. Excuse me. So these would be the three groups that I would kind of want you to be able to recognize. We have this group over here, which is going to be called our prisms. We have this group right here, which are going to be called our pyramids. And then over here, we have this final group, which I typically phrase as our other. I mentioned to you about the cube just a minute ago, and the cube fits our prism category, but we can also put it into the other category because it doesn't actually get called a prism. It just actually has that special name of cube. So at this point, what I'm going to ask you to do is we will close this part out, and I am going to ask you to head on over then to your notes packet. And we're going to be starting on page 2, talking about naming solids and edges on lesson 9.1 here. So the first thing that you need to do is understand a couple vocab terms that go along with this. Our first one is solids. are objects that do not lie in a plane. A plane would be exactly like a flat piece of paper. So in other words, when we talk about solids, they are not flat. They have length, width, and height. So if you're thinking about three-dimensional, these are our three different dimensions that we have: length, width, and height. So we are going to go on, and like I said, we are going to talk and group our solids for right now into three groups: prisms, pyramids, others. For prisms, these were the ones that we saw kind of at the beginning here. Prisms are going to have two congruent, which means they have to be exactly the same, parallel bases. And that was what we saw when we saw the two sides being the triangles, the two sides being the hexagons. Those are your bases. The prisms get connected together then. Those bases are connected by a series of rectangles. The two ends that are matchy-matchy are called bases. All of these rectangles get called faces when we talk about them. For pyramids, we're going to notice that there is going to be one polygon base. So it could be a square, it could be a rectangle, it could be a triangle, it could even be a hexagon or something larger than that. So we have one polygon base. And in addition to that, all of the faces, those other sides that we see on the pyramid, are going to be triangles. When we get to the others, we're talking about the cube, we're talking about the cone, we're talking about that sphere. And if we split a sphere in half, we actually call it a hemisphere. So if you're thinking about like the top of an ice cream cone. And the reality is that these all kind of have special properties, that they don't necessarily fit completely into one of these other groups. So, and they also are named slightly differently than the others. So that's going to be kind of our difference between prisms, pyramids, and others. So when you take a look at a solid, for example, at the bottom of page 2 here, you have a common list of common solids. So when we actually look at these, you'll notice that the prisms are all kind of right here. We have a triangular prism, a rectangular, a pentagonal, a hexagonal, and an octagonal prism. Those, when we name the prisms, they have their bases are part of their name. And that allows us to identify the difference between the different prisms here. So we actually look at those bases and we turn that word, a pentagon, and we add an AL to the end of it, which makes it into an adjective. So it's actually a describing word for what type of prism we have. So we see the different prisms that are on here. You can also see some of the different pyramids. And obviously this isn't the exhaustive list. These are just the most common ones. But you can see that the pyramids are also named by their bases. So we have the square pyramid, the rectangular, the triangular, pentagonal, hexagonal, and octagonal. And no, we don't call it octagonal. We say octagonal. When we get to the other ones, that's going to be like your cube, your cylinder, your cone, your sphere, and even that hemisphere that kind of got thrown into the middle here in between everything. So naming solids, we're going to be looking for the most part with prisms and pyramids. You use their base name as part of the actual name of your prism or pyramid. And then for all the special ones, they just have special names for them that get identified. If you flip on over to page 3 in your notes packet, we can talk about a couple other pieces that appear on three-dimensional solids. For example, we have edges, and edges are exactly what you think they are. They are going to be the point that the lines that actually connect sides together. So we actually have a special type of edge that's called a base edge. And if you remember, the base is going to be like the bottom, or on a prism, it's going to be the two ends that actually match. So a base edge would be any one of these sides that actually create the base of your object. So for example, AB would be a base edge. We could also see BC. We would also be able to say CD, and we would also say AD. Those four sides around that base are going to be considered base edges. In addition to that, you'll notice on this one that we also just have these edges that are right here that actually connect those two triangles together. So we have, for example, side AE is going to be an edge. EB would be an edge. EC is going to be an edge. And ED is also going to be one of our edges. A vertex is really just a point. So it's where you have more than one edges actually meet up. And on this particular square pyramid that we have here, or rectangular pyramid, this is actually the point E, which is going to be our vertex here. So we have some parallel and perpendicular lines that we want to take a look at. Sorry, I'm trying to see if I can get my camera back up here, but it looks like I can't. So when we talk about parallel lines, you've talked about parallel lines before. They're the ones that are parallel to each other. They are never going to touch. They're always the same distance apart. And one more thing that we need to add here now is that they lie in the same plane. And like I said before, a plane is like a piece of paper. So you have to be able to put a piece of paper through them. For example, looking at this triangular prism right here on the right, BE and CF, we could put a piece of paper through them. BE and CF are also going to be parallel because they're the same distance apart. They'll never touch. In the similar manner, we could also say AC, which is up here, and DF, which is over here, would be another example of parallel lines then. So those aren't the exhaustive list, but that gives you a couple examples of it. If you take a look here, we have one more definition, which is going to be skew lines. And skew lines are in different planes. So it's basically like we would need some different pieces of paper. But the crazy cool part about skew lines is that they also will never touch. And a lot of times what you're going to see here is that one of the lines is going to be moving in one direction while the other is going to go in another direction. So I'll point out to you, for example, here, if we have BC, which is kind of coming down at this slant here. And then we have DF going across the back here. These are in different planes. We would actually need two separate pieces of paper to represent them. We couldn't have a flat sheet of paper that would be able to maintain both of these pieces. However, BC and DF will never touch each other. They are going to stay basically what we would think parallel because they'll never intersect each other. However, because they're in different planes, we call these skew. So for example, BC and DF. Another set of skew lines would basically be if I had up at the top here, if I had BE that was kind of going side to side, and then I had AC, which was lower down over here and kind of coming out and going left to right, whereas like this one's kind of coming forward. So another example that we would have of skew lines would be AC and BE. And we would actually see that in this picture up here. I'm going to ask you to just take a second here real quick and look at this prism that we have down here. Notice that it has 8 sides to it. So this would be called an octagonal prism. And what I'd like for you to do is see if you can identify a couple parallel lines and see if you could identify some skew lines here as well. So with that, there's one more piece to our lesson for today, just kind of talking about faces, edges, and vertices on the solid. So for this first one, this is a type of prism, and it does say to identify it, so that's what I'm going to do first. The two sides that are matchy-matchy have 5 sides to them, so we're going to call this a pentagonal prism. So that's going to be item number 1. Because it is a prism, we know that we have 2 bases. The faces are all the rectangles that connect them together. If we count up all those rectangles, there are 5 of them connecting. Edges are going to be any of our lines. So going around the side, we have 1, 2, 3, 4, 5. We also have 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So there are actually 15 edges that are on here. I'm going to erase this picture real quick because our next task is to figure out our vertices. Vertices are the points where you have 2 or more edges meeting. So that would be like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So you would have 5, 15, and 10. For the last part, we have a triangular prism here, excuse me. So we have a triangular prism. The 2 bases are triangles. They are connected with rectangles, and those are called the faces, which is 3 of them. Edges, we actually have 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. And if we're counting up our vertices, we have 6 total vertices on here. So that's a lot to take in, definitely a lot to look at for this particular lesson, but we're going to practice a little bit with it. You have some practice packet work to do and some other things that will kind of help out with practicing the naming and talking about all those different things that have to go along with naming our 3D solids and their sides.